All right, for question 9, we're going to factor over the complex numbers, and then we're going to write the factored form, and we're going to give its complex zeros. Meaning we're just going to factor it completely, and we're going to give all the zeros just like we did, except this time we're going to more than likely be dealing with our imaginary numbers. So we have x to the fourth minus 5x squared minus 36. So we need to know what times what gives me negative 36, but adds to be a negative 5. If I know my factors for 36, let's see, it's not 3 and 12, it's going to be 9 and 4. So I need a negative 9, positive 4. I know I'm going to get x squared minus 9 and x squared plus 4. Again, because I have x squareds in my factors, I'm always going to double check. Are they difference of squares? The first one is, so I know I'm going to have to do a difference of squares for it. So I know if I took the square root, it becomes x minus 3, x plus 3. And then that final one is going to be the x squared plus 4, because you cannot do the sum of two squareds, so he has to stay the way he is. So this is my factors. So of course, if I were to solve the first two, I know that my x is going to be plus or minus 3. So my next one, I have x squared plus 4. Set it equal to 0. We subtract. We get x squared equals negative 4. To solve, I know I have to do the square root. And this is where my imaginary number occurs. So I know I have to pop out the I for that negative, and I'm going to have to take the square root of 4, which is 2. So I get a plus or minus 2i. So that is, oops, sorry guys, that is also part of my answer. So I have plus or minus 3 and plus or minus 2i as part of my zeros. All right, B. I have 4 terms, so of course I'm going to group. First 2, second 2. I'm going to take out an x squared, and I'm going to take out 16. I get x squared with an x plus 2 remaining. Take out 16, and I get an x plus 2 remaining. I'm left with x squared plus 16, and then x plus 2. You might be very tempted to say, oh, I can factor x squared plus 16, but you cannot, because it is a sum of two squares. You can only do the difference of squares. So this is your factors. Oh, goodness, there goes. This is your factors. Now we have to give our x's. We should know that the first one is going to be minus 2. But you might have to come over to the side. X squared plus 16 equals 0. Subtract. X squared equals negative 16. You're taking the square root. So you're going to get x equals, square root of 16 is a plus or minus 4. That negative is an I, so plus or minus 4i. And I like all of my answers to be together, so I always make sure that they are all in the same area. All right, so now we're going to move on to our next set. And it tells us specifically we are going to solve the following quadratics using, very specifically, the quadratic formula. Now I'm going to make a little correction here to our notes. So each one of these, because they are solved, we know that we are going to set them equal to 0 in order to actually solve them. All right, so quadratic formula. For A, I notice I have just an x squared plus 42. Remember that A is a 1 A is a 1. That B, because he is not there, there is no just X by himself, he's a 0. And of course C is 42. And of course we have to remember that the quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. So we're going to use this to help us solve. We have negative 0, square root of 0 squared, minus 4A is 1, C is 42 for 2 times 1. All right, so zeros don't matter, so we're just going to say that this is a plus or minus the square root of, well, we need negative 4 times 42. Negative 4 times 42 is 168. Over 2. We are going to, we're going to break down that 42, except we really have already had it broken down, so we know that it's actually square root of 4 times 42. So that's, we know that we're only going to take the square root of 4 because 42 technically only breaks down to be 2 times 21 and 2 times 21 and 7 times 3. So we cannot take the square root of any of these. So we know that we're going to end up with plus or minus square root of 4 is 2. Square root of 42 over 2. That 2 over 2 reduces so that we're just left with plus or minus. Sorry, that should be a negative. I lost a sign right here. Negative. This should be a negative underneath here. This should be an I plus or minus I, actually 4I, 2I with the square root of 42. Sorry, guys. So that 2 over 2 reduces to be just a 1. So that we have plus or minus I with the square root of 42. I do not need to write 2 of these. I don't have to write I square root of 42 and a negative I 42. You can leave it as just plus or minus. We know that that represents 2 answers. Looking at B, we have A is a 1, B is a 2, C is a 6. So very carefully when I plug it in, I'm going to have a negative B plus or minus the square root of B squared minus 4AC over 2A. I end up with a negative 2 plus or minus. So 2 squared is 4. And then negative 4 times 6 is a negative 24. So 4 minus 24 is a negative 20 over 2. Make that smaller. I cannot have a negative, so I know I'm going to pull out the I. So I get a negative 2 plus or minus I. And 20 breaks down to be 4 times 5 over 2. Negative 2 plus or minus. I can only take the square root of 4, so that becomes a 2I with the square root of 5 remaining over 2. Now, if I know anything about reducing, I can either split these apart or I can look at all of them and go, okay, that's a 2, 2, 2. All 3 terms have a 2, so I can reduce them all down. So I get a negative 1 plus or minus the square root of I with the square root of 5 as my answer. Now again, you don't have to split it apart. You do not have to tell me -1 plus I square root of 5, -1 minus I square root of 5. You don't have to do that unless you absolutely just are determined to do it. Otherwise, you can leave it as plus or minus. All right, C. We have an A as 1. Sorry, guys. A is 1. B is -2. C is a 5. Very, very carefully when I plug it in, I know I get a negative B plus or minus the square root B squared minus 4AC over 2A. Now you might think I'm nuts for sitting here and saying the B's and the A's all over again, but it helps me to remember when I go to plug them in, I need to make sure that they are plugged in with their signs very carefully. So that negative negative becomes a positive 2 plus or minus the square root of -2 squared is a positive 4. -4 times 5 is a -20, so that's 4 minus 20, which gives me a -16. If you need to write it down, remember that's 4 minus 20 inside there over 2. That negative pops out to become an I, and that square root of 16 is plus or minus a 4, so that is 2 plus or minus 4I over 2. I get to reduce all of these. You can break it apart so that it's 2 over 2 is 1, plus or minus 4 over 2 is going to be a 2I. Now, D. This is going to be a big one because we're dealing with slightly larger numbers. But that's okay. We're going to take our time and we're going to be very careful with it. So we have an A of 9. Our B is -4 and our C is 11. Negative B plus or minus the square root of a B squared minus 4, A is 9, C is 11, all over 2A. I get a positive 4 plus or minus. I'm not going to skip this step. I'm actually going to do this one. Let's see. 4 is 16. -4 squared is 16. 99 times -4 is going to be a -396 over 18. So now I have a 4 plus or minus the square root of 16 minus 396 is -380 over 18. I need to break down that 380. So what I'm going to do is I'm actually going to come over here to the side. I know that 380 breaks down to be, what's that, 95? Yep, 4 times 95, and then I'm going to break down that 95 so that it becomes a 2 times 19. Okay, so the only thing that I can actually take the square root of is that 4. So I'm going to take the square root of 4 and pull him out to the front so that I get a 4 plus or minus what becomes a 2i with a square root of 95 left over, then 18. Reduce it so that 4 over 18, that becomes a 2 plus or minus, that becomes just an I, square root of 95 with a 9 in the denominator. As my final answer. All right, last but not least, there's always word problems. But this is okay. We're going to practice it. It's always good to practice it. All right, so for 11, it says we want to write the slope intercept, meaning I want it to be y equals mx plus b. That will model the following situation. It says use the equation to answer the question, and then we're going to graph the slope-intercept form of the line on a coordinate plane using the appropriate intervals for x and y axis. All right, that's a mouthful. All we're going to do is we're going to read it, and we're going to make our equations. So it says, and then we're going to solve, sorry. A tank fills at a rate. Ooh, rate. He definitely is going to be my slope. So a rate of 150 gallons per minute. And initially has 750 gallons. There's my equation right there. I have a starting value and I have a rate. So I know that my equation is y equals 150x plus 750. Our x in this case represents our minutes because we start with 750 gallons. And it says, how long will it take for the tank to reach 6,900 gallons? Well, if our input is minutes, our output is gallons. So I know that my output is 6,900 equal to my equation of 150x plus 750. And I'm going to take that and I'm going to solve it. So I get minus 750 on both sides. So that I'm going to bring my equation over here. I get 6150 is equal to 150x. If I divide by 150, I should get x equals 41. But I do not, because I'm given a word problem, I need to make sure that my answer always has words with it. So it's not 41 gallons, it's 41 minutes. Because that's what my rate said that it was. It was minutes, it was gallons per minute. So this is a 41-minute answer. All right, for B. Helen purchased a state-of-the-art oven in 2000 for $50,000. And the stove is now worth $20,000 in 2015. If the stove depreciates, very important, we know that it's going down in value, depreciates at a constant rate, how much will it be worth in 2017? Well, anytime I'm dealing with time or years, my starting year will always be my 0. So I'm going to put, my starting year in this case is 2000, but instead of 2000, I'm going to put 0. And I started with a value of $50,000. So 50,000. The next year, so 2000 becomes 0. The next year I look at is 2015. Well, the difference between 2000 and 2015 is 15. So I know my next year is 15. And it went down to 20,000. I have to find my slope first. So I'm going to do 20,000 minus 50,000 over, let's see, 15 minus 0. So that I get negative 30,000 over 15, which is actually negative 2,000. So back to my equation. I need it to be y equals mx plus b. So I get y equals, I know it depreciates by 2,000 per year. And it started at 50,000. And it wants to know how much will it be worth in the year 2017. Well, in 2017, remember, 2000 is 0. So 2017 is going to be 17. So that's what I'm going to plug in. So I get negative 2,000 times 17 plus my starting value of 50,000. Plug everything into my calculator, and I will get y equals $16,000. All right, so the key thing that I actually really want you to take away from this one is whenever you're dealing with time, you're going to always do your starting value as 0, and everything after that is going to be the difference between your starting value and the next value. All right, for C, it says Mac's house was purchased for $250,000 in 2010. So that's its initial value, and it is expected to appreciate at a rate of $12.25 per year. It wants to know how much will the house be worth in 2021. Well, we're going to write our equation first. We know that it appreciates at $12.25 per year, and it started at $250,000. Now, the difference between 2000 and 2021, 2010 and 2021 is 11 years. So I'm not going to plug in 2021. I'm actually going to plug in 11. So I plug it in. So I get 1225 times 11 plus 250,000. Plug absolutely everything into my calculator, and you should get a value that in 2021, that house value should be $263,475. Now, there is actually something that I want to talk about that's not in these notes, but we're going to talk about the discriminant. Okay, so the discriminant. Okay, it's a fancy, fancy, fancy word to say that it's the math that occurs underneath your radical of b squared minus 4ac. Okay, this is actually what occurs underneath your square root when you are doing the quadratic formula. Now, the discriminant is really cool. It is a very quick way to figure out how many answers you're going to have and what they are going to be, whether or not they're going to be complex or real. So, if you do the math and you get a negative answer, this negative is going to tell you that there are two complex or imaginary solutions, which this makes sense. Okay, earlier when we were doing the math and we got a negative 380, we know that, well, I'll go even smaller. When we got a negative, okay, my pen doesn't want to write there. When we got a negative square root of 20, well, we ended up getting a plus or minus 2. I square root of 5 for our answer. So that gave us 2 complex or imaginary solutions. Now, if it is 0, right? If we do b squared minus 4ac and we get 0, well, that means that there's only one real solution, right? Because the square root of 0 is just 0, so there's not going to be a plus or minus. All right? And then if we get a positive answer, it means that we're going to have 2 real solutions. All right, that's all I have for week 7. Have a great week.